Good morning. Let us demonstrate the power required in blade element theory. So, the power required in a blade element theory in forward flight. For this, you will remember the following thing. Consider a one blade element and assume, of course, that we are the velocities that are attacking this angle are the tangential velocity, which is in forward flight omega r plus v cosine of alpha disk sinus up c, and the perpendicular velocity, which is vi plus v sinus of alpha disk. This will give the velocity, total velocity, and we know that this is the inflow angle, phi, and we know that angle of attack is this. So this is the angle of attack. Of course, the lift force, dl, is perpendicular to the velocity vector, and the drag, the profile drag, it is parallel with this. So you can write that the force, which is a drag force acting on the blade element, is dl sinus of phi plus the drag of the profile cosine of phi, the inflow angle. And you see also that the inflow angle is approximately v sinus of alpha d plus vi, so divided by omega r plus and v cosine of alpha disk sinus of c. So it is the tangent of that angle. It means that the power on the blade element, dp, is approximately dfx multiplied with omega r. So we neglected this part of the term. Approximately, it means that this is phi dl plus a d dp multiplied with omega r. So it follows that the drag, the power on the blade element equals with dl multiplied with v sinus of alpha disk plus vi divided by omega r plus v cosine of alpha disk sinus of c multiplied with omega r plus a d profile multiplied with omega r. What we are going to do now is we are going to add and subtract the following term. Hope I have here enough place. dl v sinus of alpha disk plus vi divided by omega r plus v cosine of alpha disk sinus of c times v cosine of alpha disk sinus of c. I will show you why we do this. So adding and subtracting this term, we arrive at the dp, the power on the blade element, equals with dl multiplied with v sinus of alpha disk plus vi divided by omega r plus v cosine of alpha disk sinus of c multiplied by omega r plus v cosine of alpha disk sinus of c minus dl multiplied with v sinus of alpha disk plus vi divided by omega r plus v cosine of alpha disk sinus of c multiplied with v cosine of alpha disk sinus of c plus dp multiplied with omega r. So this is equal with dl multiplied with v sinus of alpha d plus vi minus dl sinus of phi sinus of c multiplied with v cosine of alpha disk plus again ddp multiplied with omega r. But you remember that the thrust is almost the lift on the plate element. And you remember the HI forces, which are approximately dl sinus of phi sinus of c. So now you understand why we did this mathematic change. It follows that the dp equals with dt, the thrust, multiplied with v sinus of alpha disk plus vi plus an dhi v cosine of alpha disk plus ddp multiplied again with omega r. Now we are going to integrate around the radius and then around the azimuth. It follows that the power of the rotor, it is T multiplied with V sinus of alpha disk plus number of blades divided by 2 pi integral from 0 to 2 pi dc integral from 0 to r from vi dt plus hi v cosine of alpha disk plus n over 2 pi integral from 0 to 2 pi again from the azimuth integral from 0 to r from ddp omega r. But if you remember, this term, it is the power induced. And also, if you remember, this term is the profile drag power. So, we have the following. What is the term? What is this term? What is this term? This term that we need to calculate. For this, I'm going to recall the equilibrium of the rotor in forward flight. Imagine that this is the rotor, the tip of plane, and imagine that this is the horizontal. So the helicopter is flying with a velocity. I assume that all the mass is concentrated in this point. Sorry for the pen. So there are the following forces. The force is Hi, the force is H0, of course the weight of the helicopter, the drag of the fuselage, and the thrust that we learned that is directed forward. This is the angle alpha disk, and gamma is the flight path angle. So this is the velocity vector. If you write the equilibrium of forces here, you have that T thrust multiplied by sinus of alpha d plus hi cosine of alpha disk equals with h0 cosine of alpha disk plus the drag of the fuselage plus weight multiplied by the sinus of gamma. So in a climbing flight. So this is what we needed. We needed to know this term, and we arrived that this is equal with this term. Substituting this term into the previous slide, we get that. So the power equals with h0 v cosine of alpha disk plus the drag of the fuselage multiplied with v plus weight, velocity, sinus of gamma plus induced power plus profile power. So it follows that I go back to red. This is the so-called drag power. This is the parasite power of the fuselage. This is the power to climb of the helicopter. This is the induced power, and this is the profile drag power. So we have now all the summation of the powers that the helicopter has in forward flight, and we will use in the future this formula to derive each of the powers acting on the rotor. This ends my derivation on the power required for forward flight blade element theory.